Hi everybody, in this video I'm going to show you how to connect and use both the anode and cathode RGB LED with the quantum system. So let's get started. So there are two different types of RGB LEDs. There's anode and cathode. They're pretty much the same device, however there's one difference. As you can see on these RGB LEDs, there's 4 pins. You'll have a red pin, and then the longest pin is either the anode or cathode pin, and then you'll have green and then blue. Now, so the big difference is for the anode RGB LED, that long pin will be the anode pin, which is going into 3.3 volts on the builder base. And then for the cathode, that long pin is going to go to ground. So that's pretty much it for the RGB LEDs. So let's go ahead and create both of these circuits. And then we're also going to attach them to 2 different builder bases and operate them independently. So to get started, let's go ahead and create our anode RGB LED circuit. All right, so for our anode circuit, we have our anode RGB LED here. You can see there are 4 pins. The longest one, that's going to be our anode pin. The single pin next to it is going to be our red pin. And on the other side of it, there's the green one. And on the very outside is our blue pin. So once we take this RGB, we're going to place it on our breadboard just like this. You want to keep in mind where that anode pin is as in reference for when you do the other pins. But now, since this is an LED, we want to use resistors to prevent it from blowing out. So I have some 100 ohm resistors here, and that's what we're going to use for the red, green, and blue pins on our LED. So go ahead and take one 100 ohm resistor and attach that from the red pin, and then just cross it over the gap here, and then continue onto this row as well. And then we're also going to do the same for our green one. So remember, it's the red, then it's anode. You want to skip the anode one, and then connect this resistor to the green, just like that. And then take your third resistor, connect, and then use that for the blue pin. There you go. Now since this is anode, that anode pin is going to be connected to 3.3 volts on the builder base. So I'll just take this red male-to-male jumper wire. I'll attach that to our anode pin. All right, so let's just go ahead and while we're at it, take that anode wire and then attach that to the 3.3 volts on the builder base. Just like that. Now let's go ahead and wire each of the color pins and attach it to the builder base. So the first one I want to do is the one on the very left, and that's going to be our red. So I'm going to take this orange jumper wire, and then from where the resistor is on this row, plug it in there, and then attach this to GP0. Next, I'm going to grab my green male-to-male jumper wire here, and then I'm going to attach that to the resistor that's attached to the green pin, just like that. And then I'm going to take the other end and screw it into GP1, just like that. And now I'm going to take this blue male-to-male jumper wire and attach that to the same row as the resistor connected to our blue pin on the RGB LED, and then attach that to GP2 on our builder base. So that's our circuit. We have our resistors for each of the RGB pins on the LED, and then they are connected with these jumper wires to our GP terminals, and then the anode pin goes to 3.3 volts. So that's pretty much the circuit for our anode RGB LED. I'm going to go ahead and assemble our cathode one as well. If you don't want to use that one, you can skip that part. However, I'm just going to keep this one off to the side and continue with our cathode. So now we have our cathode breadboard here with the LED. It's the same concept. We have the red pin. The very long pin is our cathode pin. We have the green pin and then the blue pin on the very outside. And then, so just keep that long pin in mind when you put it on the breadboard. So go ahead and connect it that. There we go. So we're going to have red pin, cathode, green, and blue. So now again, we have to connect the resistors to it so the LED doesn't blow out. It's just good practice. So I have another 100 ohm resistor. I'm going to connect that to the red pin and then cross it over to this side of the breadboard. And then for the green pin, I'm going to do the same, just like that. And then another one for the blue pin. There we go. So now since this is cathode, that cathode pin, we're going to connect a black male-to-male jumper wire here to that pin. Just like that. And then now we can just wire it to any ground terminal on our builder base, just like that. Now let's continue by hooking up our red pin on the RGB LED. I have this orange jumper wire. I'm going to connect that to GP0, just like that. I'm going to have a green one for the green pin. Plug it in, and then I'm going to connect that to GP1. Now I'm going to take this blue jumper wire and then connect that to the blue pin on the LED, and then the other end is going to go into GP2, just like that. So that's our cathode circuit. So now we have both of our anode and cathode circuits here. Let's go ahead and power these on and then do the rest of the setup on our Q server. So now that we're on our Q server, before we start anything else, I want to show you all our RGB LED hardware reference, which I'll have linked in the video description below. This will go over the cathode and anode pinout for how to set it up with the builder base and the quantum system. And it also goes into a little bit more depth with all the information that you need about these LEDs, also how to create the app and the firmware and so forth. So be sure to check this out as well. And so now let's just go back to our Q server. Once we're back at the server, we have to pair both the builder bases. So let's go ahead and go to clients and then go to the unpaired tab. Now you can see here that we have both our builder bases here, but they're not named or labeled, so we don't know which one is which. Don't worry if you don't know which one's which. Just go ahead and pick one, go to actions, and then select pair. Once that client is paired, don't click the setup button. We're just going to click close. And now we're going to go back to our paired tab, and that new one that's paired, go to actions and then select identify. When you select identify, I'll do it one more time. Identify, you'll see that it's on our anode circuit here. So now I'm going to just click actions again, select edit, and then I am going to label this RGB anode and just pick a location. And there we go. Now I'm going to go back to that unpaired tab and go to actions, and I'm going to pair that other builder base, which I know out of process of elimination is our cathode builder base. So I'll just select setup this time. And then for the name, I'll create RGB cathode and then location, pick studio. There we go. Now we have both our builder bases, the anode and the cathode. Let's go over to our firmware builder and create the firmware files for each of these. Go ahead and select the firmware tab. We're going to click create new. Now we're going to have to create a firmware file for each builder base. So this one we'll do RGB anode. I'm going to click create. Now I'm going to add an RGB LED hardware to this. So yeah, there we go, LED RGB. This one I'll name RGB anode, and I'm going to add that hardware. Now I'm going to select the drop down. Now for driver, I'm going to select GPIO. For the red pin, I'm going to select GP0, which is the one I have connected right here. For the green pin will be GP1, and then blue pin will be GP2. Now for the layout, this is where you're going to have to select common cathode or anode. So since I know this one's the anode, I'm going to select common anode and then click save. So let's go ahead and go to actions, click upload, and then I'm going to select the RGB anode client. So go ahead, select that one And now, click upload. And while that one's uploading, let's go ahead and create our cathode firmware file. So I'll create a new firmware, name this one RGB cathode, click create. I'm just going to move that out of the way. All right, now we're going to do the same thing. We're just going to add an LED RGB hardware. I'm going to name this one RGB cathode, add hardware. Now for the driver, it's the same thing. And then now I know for the cathode, it's going to have the same setup with the GP terminals. So red pin is GP0, green is GP1, and blue is GP2. Make sure you assign these accordingly on how you set it up if you did it differently. And then now for the layout, this is for the cathode. So I'm going to select common cathode and then click save. Now I'm going to go ahead and go to actions, select upload, and then pick the RGB cathode client and select upload. All right, now we have both our firmware files uploading to the correct builder bases. Let's go ahead and create our app while those are still uploading. So go ahead and go to the apps tab, click create new. For this, I'm just going to name it RGB LED. And now once we're on our canvas, we're going to have to bring out two RGB LED hardware objects, one for the cathode and then one for the anode. So once we bring these out, go ahead and change the object name. I'm going to name this first one RGB Anode and then click Save Properties. Now you can see it up here. This will help with the mapping process too afterwards. So for the second one, I'm going to name RGB Cathode. And there we go. So now once both of these are named and labeled correctly, now we want to create a simple app that controls them. So what we want to do now is bring out a couple color pickers, and this will adjust the different colors on the RGB LEDs. So I'm going to drag one color picker out. It's an interface object. I'm going to drag that to the anode. And then I'm going to drag another one to our cathode. And we are going to name them accordingly. So this one will be RGB Anode. And I'll label it the same as well. Click Save Properties. This one will be for RGB Cathode. There we go. Now click Save Properties. Now this will be our app. Very simple. Each color picker will just control one RGB LED. So now I'll just click Save. Return to my apps. I'm going to run the app. And now for the RGB cathode, I'm going to map that to our RGB cathode client with the firmware hardware, and then do the same but with the RGB anode. Now I'm going to click Save and Run, go to our dashboard, click the RGB LED app. And now we have one for our RGB anode and then our RGB cathode. So when I click Edit for the RGB anode, we'll have this color slider here. And then say I want to select this aquamarine color, and I click Save. You can see that the anode RGB LED displays that color. And then you can also see that it gives a color code for that color you selected. If you want to use that to have a set color sent to the RGB LED when it's triggered, you can keep that code in mind. We'll be doing that in our next demo, which I'll go over in a minute here. However, here's our RGB anode. So I want to change that to a pink color now. Now it changes the pink. And then for the RGB cathode, so I want it to be green. You can see it turns green. Or if I want it to be dark blue, you can see it turn blue. So that's it on how to use the color pickers with the RGB LEDs, and then how to set up both the anode and the cathode. So that's just our first demo. The second one, we'll take it one step further. We're just going to use one of these RGB LEDs. It doesn't matter which one, but then we're going to create an app where we'll have this ultrasonic sensor, and based on the distance, we're going to have the RGB LED display either a red, a yellow, or a green color. So I'm going to go ahead and just pick the anode RGB LED, move the other one out of the way. I'm going to set this one up off camera. If you want to know how to set one of these HC-SR04 ultrasonic distance sensors, I'll have a video linked in the description below. So make sure you check that out beforehand if you want to do this demo. So however, I'm going to build this and then we're going to go back to our Q server and do the rest of the setup. Okay, so I have my ultrasonic sensor here. It's all set up on our builder base. The firmware is uploading right now. But before we create this app, I want to go back to our old app and collect the different color codes for the RGB LED that we want to use. So I want to use a green, a yellow, and a red. So let's go back to our Q server here. I'm going to quit out of notifications, go back to our app. I'll go ahead and just run this with the anode. I'm going to our dashboard. Now I'm going to our color slider. Now, so the first color one is red. I'm going to go all the way to red, click save. You can see my anode RGB LED is turning red. That's about the color I want. As you can see, this here is our color code for that. So I'm just going to write that down. On a separate piece of paper here. All right, there we go. Now I want a yellow color as well. I'm gonna pick that, click save. And you see this color looks a little green to me, so maybe I want to adjust that a little bit more to the yellow. There we go. All right, that's what I want. So this is the color code for the yellow I want to use. Zero. All right, and now next I want to use a nice green color. So that's a good one, and that's the code for it. So I'm just gonna write that one down too. Okay, there we go. Now that we have our color codes, let's go ahead and create the application for this. And I just go back to our Q server. I'm gonna stop this app. And then we can just go ahead and edit our current one here. So since we're not using the cathode anymore, I'm going to delete that one. Now we have our RGB anode. First thing we want to do is bring in that ultrasonic distance sensor hardware object. Here we go. Now this hardware object is going to give us the readings either in centimeters or inches, depending on how you adjusted your metric or units of measurement in the settings. For this one, I will be using inches. So I'll have this hardware object, and then I'm going to need to bring out a number compare object here. There we go. Just like that. Now it's going to compare the values given to us by the distance sensor, and we're going to use that to send out the different colors to the RGB LED. So go ahead and attach the ultrasonic distance sensor to the number 1 port of our number compare object, and make sure to set this to trigger. So every time it receives a value, it will trigger the rest of the program here. So go ahead and activate that and click Save Properties. Now for number 2, we can set any value we want to be the number it compares against. For this, I'll just set it to 5 inches. You don't need to turn on the trigger. Go ahead and then click Save Properties. Next, now there's a few different ways to do this. I find the easiest way is to not use the color pickers anymore since we know the color codes we want to use. You can keep these here instead if you want to be able to adjust the colors later on. However, I already showed you how to do that. We're going to do something different. So we'll delete this color picker. And now we're going to add in static strings. So we're going to add 3 of them. Just like that. So now let's go ahead and label these. This one will be red. This one will be green. And then this one will be yellow. So now you'll see why I did it this way. So when we have our ultrasonic distance sensor getting a value, if it's greater than 5, we want to display a red color on the RGB LED. If it's less than 5 inches away, we'll display a green on the RGB LED, and if it's equal to, it'll be yellow. So once you do that, we want to store those color codes into the static string. So go ahead for the red static string object, click the string port, and for value, we're going to type in the color code we wrote down for the red color. There we go. And then click Save Properties. And then for the green, go ahead and do the same thing. Click the string port, and then we're going to type in 1DFF00. There we go. And then click Save Properties. And then for the yellow, FFEA00. And there we go, Save Properties. Now we're just going to drag each of those to the RGB port here. Now we're not quite done. I also want to see what the actual distance is from the sensor. So the next thing we need to do is just go ahead and bring in a text interface object and drag from the distance ultrasonic sensor to there. That way we know what the distance is and then see how that changes with the color. And then I'll go ahead and give this a label, just call it distance, and save properties. So now this is our app. Let's go ahead and save our app. Turn to my apps, click the play button. Now we already have our RGB LED mapped. Let's go ahead and map that ultrasonic sensor. I didn't title it. However, we know what type it is. So we'll select the ultrasonic builder base with the firmware hardware. Click Save and Run. Now when I go to my dashboard, you'll see it's giving us a distance. Here we go. So if I move my hand over 5 inches, you can see it's giving us a reading of 6.3 inches. And it's giving us a red color. Now if I move it closer, you can see it's changing colors. Move it back, red, green, red, green. Now let's see if I can try to get it to yellow. It's tough trying to get exactly 5 inches. However, let's see if we can do that. All right, maybe not. So trying to get the yellow color, since we want it to pop up when it's equal to 5 inches, it's a little bit hard. And also it depends on the granularity set in the firmware file for the ultrasonic distance sensor, based on what values you set to notify the system. So it's a little bit difficult to achieve that. However, it's doing what we want. We have it green when it's under 5 inches. I move it away, turns red, and there'll be yellow in there at some point, but it depends. This is a cool little project. We've used this as a garage distance sensor before, where if a car gets closer to a wall, you can have the ultrasonic distance sensor display a color to tell you to stop, or if you still have more room. I'll also have that video linked in the video description below, so make sure to check that out if it's something that you're interested in creating as well. So that's pretty much how you use an anode and cathode RGB LED with the quantum system. Make sure you check out those links in the video description below for more information about the RGB LEDs, as well as some of the other projects we've used it for. So I hope you enjoyed this video, and thanks for watching.